Hello there, welcome to my session. Today we are going to talk about how to set up your RBAC solution using Rönd, which is an open source project. My name is Graziano. I know it is not the easiest to pronounce for those who are not Italians, but hey, I didn't choose it, so thanks, Mom. And I'm a developer relation engineer in Mia Platform, an Italian company who brings to the market an internal developer platform builder. And we are those who creates and maintains Rönd. Let me introduce what policies are in their broader meaning before jumping straight to the point. When we think at policies, we think of something that is strongly related to user access. We think of something that regulates what users can access in terms of resources and access and assets. Actually, with policies, you can define the behavior of your application. For example, by access specific attributes of your assets, like you can see on the screen by the example there. And you can define and describe invariants that must hold in your systems. So, basically, policies are a set of rules and a sort of if-then statements that describe invariants that holds in your system. And they are not necessarily associated with the users and roles. In fact, authorization policies are just a small chunk of the larger policies kinds available. The first issue you may face when start your authorization effort is which kind of access control you have to choose. So let's wear the hat of a platform builder for a moment. When you build a platform for developer teams, you have to deal with many capabilities. But to make things simple, let's discuss about few capabilities like deploy changes, commit changes, and access the project configuration, okay? In terms of personas or users, you have senior developer, which are allowed to access the project configs and commit and deploy changes. Then you have many junior developers, which can read the project configuration, commit changes, but they can't deploy. And of course, you have the platform administrator, which is able to perform all kinds of actions, including the creation of new projects. Things to scale access management in this way, trust me, is a very big mess. Think to add a new user. You need to assign to this user all the permission he is supposed to be allowed. And the same is when you create new capabilities, because you need to link all new permission related to the new capabilities to all the available users in the platform. To simplify the process, we add the roles. And in this way, when you create a new user or when you create new capabilities, you just need to link them to the role and the new capabilities are automatically inherited by the users. So, using this strategy that is called RBAC, role-based access control, you can simplify the process by abstracting out the complexity using roles that are similar to the roles that the person plays inside your organization. You have another option that is ABAC, attribute-based access control, that's used attributes instead of roles. In this case, your users are assigned or have specific attributes. In the example, you can see projects and environments assigned to the users. And to perform specific action in your product, they have to satisfy a condition that is based on these attributes. These two options have their own pros and cons. On one end, we have the role-based access control, which is much simpler, but it lacks of granularity, since to fine-grain the access to the resources, you need to add more roles, and you may face with issues like a role explosion when the things scale out. And on the other hand, granularity is a pros of ABAC, because it's much simpler to handle fine-grained access to assets with attributes, but to set up a proper strategies with ABAC, you need time and expertise. Okay, it doesn't work. Okay. The +1 option, that is maybe the best way to go, is to set up an hybrid approach, where you can use roles as an high-level access control, and then leverage attributes to fine-grain the access to specific resource. Let's make some example. Just to remain in the world of platform, we have the users that can or can't deploy changes. We have the senior developers that can deploy changes, and doesn't matter if they are assigned to a specific environment. They just need to be assigned to the project. Of course, if they are not assigned to the project, they can't access the configuration, they can't deploy the changes. On the other hand, we have the junior developers that they doesn't have the permission to deploy changes. So even if they are assigned to the specific project, they can't deploy. Suppose now that we want to allow a specific junior developer to deploy changes on a specific environment, for example, development environment or no prod. We just can assign this specific environment for the specific project and allow him to deploy changes over this project and environment couple without creating new roles and add complexity, of course. So we have many options to enforce our policies. When we start the journey, we probably just want to make things work. So the natural way to go is to have a unique code base where you have on one side the code related to policy enforcement, and on the other side your business logic. That, of course, is actually faster and simpler, but you may face issues like repetition, because if specific policies need to be used in other components of your system, you need to repeat it, and you may face issues like maintainability, and it could become a big mess. It's in this context that policies as code enter the game, and it is basically an approach to policies management where policies are defined and managed using the code. This approach uses an agent that allow us to decouple policy definition from the policy enforcement. It brings transparency because you keep your policies in a unique repository, and you can share it with all the stakeholders with a unified language. And it brings testability because you can test your policies and accuracy. The engine we need to create this approach is Open Policy Agent, which is an open source project and listed in the graduates by the CNCF. It provides basically two things. High-level declarative language, which is called Rigo, and we can use it to write our policy, and API to offload a policy decision from your systems. In this way, the code related to authorization becomes Rigo policies, and your business logic remains business logic in your application core components. Executing Rigo policies means executing these allow statements, and to allow a specific request, you just need that one of these statements is true, so the request is authorized. And with Rigo, you can define functions that you can reuse in your code. And to access the data you need to perform authorization, you can decode your JSON Web Token accessing the data from the original request. In this way, we have decoupled the policies from the application logic, but we still have a sort of dependencies, since Open Policy Agent can be integrated as REST services or as SDK libraries. But in MIA, we wanted more, and we did it by creating Rönd. Rönd was born with a clear intent in mind, that is to remove all these dependencies between our systems and the authorization stuff, okay? How we did that? We did that by designing Rönd as a lightweight Kubernetes sidecar container that runs alongside your microservices, and leverage the Open Policy Agent capabilities as a security engine for validating authorization rules. So Rönd is basically an authorization mechanism, but it also allows us to build our RBAC solution by natively integrate as building blocks concepts like permissions, roles, and user groups. To configure Rönd, we just need a simple JSON file. If it looks familiar to you, it is because it's an OpenAPI specification standard. So to configure Rönd, you just need to export your OpenAPI spec from your services and just add the xRönd property to declare the policy that will be used to authorize your specific requests. Moreover, Rönd allow you with two powerful features. The first one is the query generation, which allow you to filter the response before returning it to the clients, so you can return just a specific subset of the entire data set, based on conditions that you can define in your Rigo policies. And the other feature is the possibility to change the schema of the response before returning it, so that you can, for example, remove sensitive data by change the schema of the resource before returning it to the clients. Now, Rönd is born to address specific challenges, and the main challenge is to simplify the authorization effort when our products grow. Nowadays, in our products, MIA Platform Console runs on more than 30 microservices and the double of in terms of pods, and it enforces more than 500 policies over more than 300 routes. So Rönd is designed to be integrated with no effort, basically, in existing application by using the sidecar pattern and the OpenAPI specification. And this is an example of how we in the real life use Rönd to manage the workload deployments in our console. As you can see, we are able to use the old permission formats that were that existed before Rönd, just by searching them in the bindings that Rönd provides by decoding the JWT token. The last things I want to show you is that using Rönd, you can have a look over your authorization effort, because Rönd exposes some policy utilizations and services monitoring data. Like, as you can see from the screen, you can access data like single policy usage in terms of request, policy evaluation time, and also resource utilization per services by your sidecar container. We reached the end of the presentation, and if you would, you can scan the QR code and leave your feedback, and get some in-depth material to go deeper with this topic. You can add me on your LinkedIn network and stay in touch. Thank you very much.